Session is about Introduction to Electric Vehicles by Mr. Rahul Bollini. Mr. Bollini has over 6 years of experience as an international lithium-ion cells research and development consultant, and he has worked with Indian, American, European, and Japanese companies with hands-on experience in the lithium-ion cell engineering and the fabrication process. He has studied the energy business and also the finance from Pennsylvania State University from USA. Without further ado, I would like to invite Mr. Bollini for the session. Mr. Rahul, you can take over. Over to you. Please let me know if you can share your screen. I think we can.
Hello everyone, my name is Rahul Bollini and Namaskaram Kakinada. Ella unnaru. I'm also a Telugu person. I was born in Andhra Pradesh. And by the way, Dhruv, Vahanam is also a similar word in Telugu. Vehicle is called as Vahanam in Telugu. Yeah, so not only Sanskrit. So let's get started with the presentation. Okay.
So Rahul, you can share your screen, or you can let me know if I would do the presentation sharing for you if you want.
I'll do.
Okay, thank you. Yes, oh, it's visible.
Okay. So let's get started. So I'm going to talk about the electric vehicles ecosystem, not just related to India, but overall, across the world, like how it started and all that. So introduction to electric vehicles. What is an electric vehicle? Electric vehicles are vehicles that are powered by electrical energy. They have low running costs because they have very few components. Internal combustion engine, they have close to 2,000 parts. EVs have about 20 parts only. They don't have exhaust, no tailpipe. There's no spark plugs like a petrol engine. There's no clutch or gears. They run on a single speed system, especially the cars, scooters and all. Buses have a 2-speed system. EVs are environmental friendly because, they don't use petrol or diesel. But again, it comes from electricity, which is again, most of it is generated by coal, and government is something working on it towards making it more green. But yes, hopefully it will be done in future. EVs are more efficient. If you look at petrol diesel vehicles, the fuel is given at the engine level, and then it works very low efficient. The efficiency is about 16 to 18% only. When comparing with EVs, they go about 90 to 93% efficiency. Yeah. So history of electric vehicles. In 1827, there was this priest from Hungary. He built a small electric motor with stator, rotor, and commutator, and he put it in a tiny car. And that's how electric vehicles, the first ever known electric vehicle was born. And slowly it started picking up. That the word started spreading, and the US started adopting. In early 1900s, there was a lot of EVs on road because they were not looking. They didn't have any kind of range anxiety or something. People were looking to commute for small distances. The roads were not so good, so nobody actually cared about driving all the way to different cities on highways and all, because obviously there were buses and trains for that. And around the same time, in 1902, Porsche, which is a sports car company, they built a Model P1, and it was pretty popular in the market. But unfortunately, in 1908, Ford started manufacturing the Model T, which was a big blow to the EVs. And it was very cheap compared to electric vehicles. Electric vehicles used to cost close to $1,800, and Model T was sold at about $650. So the price made a big difference. And around the same time, the roads were getting better, and petrol prices have always been cheap in the US. So that was something which was highly adopting. The petrol vehicles actually kind of blew up. And even in the late 20th century, there were some companies like Chevrolet and all, because of pressure from the United States government. There were companies, they had to build some kind of vehicles, and so they started working on some models, but unfortunately they were very short-lived. So I'll show you the vehicles. Yeah. So, this is General Motors EV1, which was short-lived from 96 to 98, just about 2 years. It didn't make much sales, but it is something way ahead of its time. Yeah. And on the left is a charging station from 1973, which is basically a part-time kind of charging station, a slow charging station. And it was there. So basically, electric vehicles were there. It's not like it's happening for the first time. Maybe in India it's the first time, but world has seen it before. And there were issues because of this petrol cars picking up bigly, but again, it is coming back. So it's a good thing. Types of electric vehicles. Let's get started with the hybrid electric vehicle. This is something which was the first part of the revolution, especially when Toyota launched Toyota Prius. So the whole point of it is, it has a battery and a separate motor to support the combustion engine, and it is used sometime, wherever there is the vehicle is running on a slow speed, where the electric motor is able to support a little bit of, slow speed operations and all that. And whenever there is a brake or something, or the deacceleration and all, the energy would come back to the battery. So that's how it would. It's more of a range extender. It would actually increase the range of a petrol vehicle, HEV. And then came PHEV, which is a plug-in. So basically, it has a bigger battery, and this is something which can run independently. They're not really connected together. They can be connected by a switch of a button. So suppose you run out of petrol, you can go switch on the electric. If you run out of batteries, you can always go to a petrol pump and refuel. So suppose you're on a highway, you run out of charge, you can keep using the vehicle on petrol. So this is something Toyota Prius plug-in hybrid was launched, and then Fiat 500e, Hyundai Sonata, Ford Fusion Energy. So this was the second type of electric vehicle which was in the market. Um, Assuming that all the PPT would be shared with you all after the course, so I've tried to put in all the data as much as possible in the PPT, so that you can refer to it again and again in future. Yes. Again, the third type is the battery electric vehicle, which has straight up come up in India. We didn't see much of a hybrid, although there were Toyota Camry and Honda Accord who tried to make some hybrids, but that is 30 lakh plus segment, and it didn't really take off. So India is a market where vehicles sell between 10 to 15 lakhs. So battery electric vehicle was a big hit, especially Tata Nexon EV, which sells for 13, 14 lakhs. So that is the right kind of budget, which is something happening. And it doesn't have any kind of petrol engine or something. It completely works on a motor and batteries. And all you need to do is charge the batteries. I'll talk more about charging in the next few slides. And then finally, this is a hot topic, which is, people are talking about hydrogen. So the hydrogen can also be used to power a vehicle. It is also a technically electric vehicle, although the fuel is different. So in that, there is a hydrogen filled up in a gas tank, which has to be securely stored. And then during the operation, it would react with oxygen, and electron would come out, and again it would power the battery. And some companies are already launched some prototypes. It's going to take a lot of time for it to come, but it is coming. So it's not that only lithium-ion batteries are going to dominate the electric vehicle market. Maybe they will today, but in future this is something which is coming, but we don't know the timeline. So that's called as a fuel cell electric vehicle. So these are some of the system, how it's built. There is HEV, PHEV, and BEV. Let's talk about main components of an EV. So EV consists of a motor, and then there's a reducer, which is also called as a controller. And then there's a battery, there's an onboard charger, which is called as OBC. And then there's the EPCU, which is electric power control unit. So this is the schematic of a EV component. So let's talk about the components in detail. So first is a motor. Motor's job is to convert electrical energy to kinetic energy to move the wheels. It has an advantage over petrol diesel cars, especially India is famous for diesel cars. So it makes very, very less noise and vibration, so which you would get a very premium kind of feel. And then actually I've heard from a lot of people, for the first time they're riding an EV, and they are quite amazed with like no sound at all during operation. And even the engine size is smaller compared to a petrol or diesel. And there is regeneration at a big level. So whenever there's a you're putting a brake or deacceleration or something, the motor would send back the energy uh, to the battery. So let's talk about the controller. So controller is a very important aspect which many people don't talk about. Generally speaking, they talk about either the motor and the battery, and controller does make a difference because that is like the heart of the vehicle. So that kind of that controls a lot of things. So it controls the RPM, and sometimes there's a lot of energy coming in, or it actually regulates the voltage from the battery, and it cuts off the battery. There are many things happening at a controller level. So I've written it all. You can refer to it later also. Let's move on. Then let's talk about battery. So I come from the battery field. So I've been working from 6 years since I am from battery, and I've worked at a very R&D level. EV companies are curious what kind of batteries to use, when to use, and what is a good battery, what is a good range, and those kind of things. So I have been extensively working on the ground with EV companies. That's why I'm today presenting about EVs. So batteries, yes, the job is like it's like a fuel tank. Its job is to store electrical energy, and people keep asking all the time, how do I get a better range? And also all about batteries. If the size of the battery is bigger, it's going to give you more range. So it's as simple as that. And then again, obviously it depends on the motor. If the capacity, if the motor is a very high power motor, then it's going to reduce the range. So it has to be balanced. And that is something, Indian EV companies are just considering, because there was a good wave of EVs. Many companies just entered the market, and they started making vehicles, and there's a lot of improvements happening. Like one in the chat box, I saw someone asking about what are the challenges faced by the EV companies. So I was actually mentioning over there that there are a lot of companies who enter in a hassle and just build because of the high demand. So someone has to supply it. I understand from the market perspective, but from the R&D perspective, I highly feel that they have to test their product on the ground, and based on that they have to take a call. Like this geography, suppose you're in Kerala, it's filled with hills, so you need to design a vehicle which is going to go uphill. The last time we had a trial with a bus company, so the bus never reached the destination because in Kerala, it was happening in Kerala. It's a very reputed brand, I don't want to name it, but it happens. So geography becomes a challenge. Similarly, if you are in a hilly cold place, say Shimla or something like that, their temperature matters. So battery has a lot of aspects. Sometimes people just think, okay, what is the voltage, what is the AH, and just design a battery. It doesn't work like that. You have to understand the ground reality, which is all the time I'm emphasizing on it. Like I was telling about Shimla. So if you are doing something there, it snows over there and the temperatures are really low, charging time takes a lot of time, and even the range reduces because the batteries don't perform very well. Some of the chemistries don't perform very well in minus temperatures. Some of the batteries don't even charge. I'm not trying to scare anyone. I'm just telling, there are challenges. So people need to understand that. And R&D is a very good scope. I always, suggest engineering students and all, get into that. Don't just look for salary packages and all. Try to learn the product as much as possible. And then, you would get a good hang over it. And then there's an onboard charger, which is, whose job is to, convert AC to DC. So it is put in a vehicle, and it is used for a level 2 charger, which again I'll be talking again. It's a slow AC charger. Yeah. Mhm. Let's talk about electric power control unit. So this is the complete system for an efficient integration of all devices to control the flow of electric power inside the vehicle. So it consists of an inverter, LDC, which is low voltage DC to DC converter, and a VCU, which is a vehicle control unit. Let's talk about the inverter. Inverter converts the batteries DC into AC, because most of these cars they use AC motors. So scooters use BLDC. That's a different thing. So I'm talking more about perspective of car, because that is something, a fancy thing, and it needs a lot of adoption, and the adoption is kind of slow compared to scooters. So scooters is doing big time. In fact, last year about 25,000 scooters were sold, but this last month alone 10,000 were sold. So the pace is picking up, but cars have their own challenge and all that. So okay, so let's talk about low voltage DC to DC converter. This basically converts electricity from EV's battery, which is batteries are usually high voltage. There are some cars using 72 volt, and they go all the way to 400 something, 380 to 400 volts, depending on the motor capacity. Uh, so suppose let's talk about Tata Nexon EV. They use a 320 volt motor and the battery. So the job of a low voltage DC to DC converter would be to convert that high voltage to 12 volts, so that it can supply to all the supply energy to all the various electronic systems in the vehicle. You might have seen there's a charging plug in the vehicle and all in a car, which is a 12 volt system. So that needs 12 volt system. So it's the job of the LDC to do that. And finally, the vehicle control unit. Vehicle control unit is arguably the most important component, because its job is to take care of all the things and manage and record. There's a lot of data, and and also including control of the motor control, regenerative braking control, AC load management, and power supply from the electronic systems. Let's talk about types of batteries in an electric vehicle. So these are something, the industry started with lead acid batteries, especially e-rickshaw markets and the scooters. And slowly they have shifted to lithium-ion batteries now. And hybrids were using nickel metal hydride, which is also called as NMH. NMH failed because the cost was too high and it had a lot of issues. There's a lot of hydrogen discharge whenever the battery is aging, and it was hard to control hydrogen. And hydrogen is something very serious. You're not supposed to let it out just like that. And lead acid, they failed because it's not like they failed. Even today, if you go to some states, the e-rickshaws are run by lead acid battery, but they have a challenge of having a very short calendar life and cycle life. They take up a lot of time to charge. They don't support fast charging. And lithium-ion batteries picked up because they support fast charging. They are portable, so you can actually fit in a lot of battery sizing compared to lead acid batteries, and you get a higher range because every vehicle has a space constraint. And but the customer wants the end user wants highest of the range. And then there is ultra capacitors, which is something people are talking to put it in on the side or something like that. Its whole job is big. Ultra capacitors basically, they work with a principle that they charge and discharge very fast. So whenever there's a high power requirement, they can support, and they have a very long life, but they are super expensive and they take up a lot of space. In fact, they take up more space than lead acid batteries. But that is something companies are considering. And then there is super capacitors, which is similar but obviously superior. Hmm. So let's talk about lead acid batteries. I already explained that they have a poor calendar life and all that. And specific energy is basically energies to weight ratio. They are on the heavier side and they take up a lot of volume. And they have a poor performance in cold temperature. And but the good news is advanced high power lead acid batteries are being developed. That is something which is being worked on and might be considered. But again, price will dominate in a country like ours. So once if the pricing is good, maybe e-rickshaws or something like that can be worked out. But I see it more of a thing which can go in the stationary applications like UPS or something like that. But it is happening. It's not that lead acid batteries are going to disappear. They are here to stay, but maybe for a different application. And about lithium-ion batteries, a little bit. This is where I come from, basically. So they are the most portable, battery available today. And obviously, they have a lot of chemistries like LFP, NMC, NCA, and many more actually. And our cell phone uses something called LCO. It has a lot of chemistries. So in India, we focus mostly for EVs. We focus on LFP and NMC. So like I said, consumer electronics like cell phones, laptop, they use LCO, and those things happen. So those things are there, and they have a high power to weight ratio, so they can deliver high power for a given mass and high energy efficiency. Lead acid battery operates at about 78% efficiency. Lithium-ion batteries anywhere 93 to 95%, and they can perform at high temperatures, and they have a low self discharge compared to other batteries. So low self discharge, they have a self discharge of less than 5% per month. So suppose you leave your EV fully charged and you're gone for like 3 months or something, you don't need to worry that the battery is going to discharge. Unlike a starter battery in a car or a scooter, you're gone for a few months, you come back, the battery is gone, and all you are worried about charging it and all that. So you don't face that kind of issues. So it's okay, you can adopt an EV and not be worried about this factor. And then NIMH, like I told before, they have a good life, but they are expensive. But that is something which were considered back in the day when Toyota Prius came, and that time lithium-ion batteries were not very matured, and people were not very confident because it was a new chemistry. LCO was dominating and NMC was just coming in and all that. But now NIMH batteries are completely outdated. So like I was saying, it's hard to control the hydrogen loss. There's a hydrogen escape happening, and that is something little hard. So that's why it is kind of eliminated. But this was there at some point, so that's why I'm actually talking about it. Battery management system. So this is something put in a lithium-ion battery. So when you're making a battery pack, the process, how it works is you take the cells, you put them on cell holders, and you put nickel tabs, and you do spot welding, and then you put the cables, connectors, and connect the BMS. So this is the BMS, the battery management system. Its job is to basically take care of the whole battery to make sure it's healthy. And additionally, it can calculate data, report data via various communication protocols such as Bluetooth, CAN, UART, etc. Suppose you have an electric vehicle, and you are able to see the range of the vehicle on your cell phone on an app or something. So it is something which is in communication from the BMS to the VCU, which is the vehicle control unit, and VCU to your cell phone. So it's all done via Bluetooth. Uh, let's talk about its functions a little bit more. So it monitors the state of the battery. So battery is the major thing that it takes care of is the voltage. It takes care of the voltage protection on the top and bottom, the lower cutoff and the higher cutoff, and then the temperature. If the battery is heating up too much, it would just shut down the battery. I know it sounds like, maybe the vehicle is going to shut down in the middle of the road. Yes, that would happen if you are kind of misusing the way it's driven. So you are supposed to drive at a decent nominal speed. You can't keep accelerating at all time. I'm sure it happens with cars also, where the radiator is gone, it's heated up, and there's a thick smoke coming out of it. So it happens. It's not something that only EVs are going to get. So let's not assume things here. And calculation of various parameters. So it talks about state of charge. That's how you get to know what is the percentage left, the energy left in the battery. So that is basically SOC. And then SOH is basically the health of the battery, how much the battery has degraded. On day one, when you buy a vehicle, say it has 100 kilometers, it's not going to give you 100 kilometers range for the rest of its life. It is going to reduce. So that is basically called as battery degradation. So how it is degrading, say 93% of it is left. So state of health would be talking about it. Say if you have an iPhone, there's a battery section where there's a battery health section. You go in there, you can actually see the battery's health. So when it reaches 80%, the iPhone would give you an alert saying it's time now that you change your battery. So, and then the state of power. So, this is more of a used in a stationary application or something like that, where, if the connected loads are continuous, and it would actually tell you uh, how long the energy is going to be, flowing with your existing conditions of usage. And then state of safety, how safe the items are, and the things are inside, if any safety issues are going to arise, or it's already happening or something like that. Based on that, we'll take a call to cut it off. And then there is a maximum charging current, and discharging current, and many more parameters. And another thing is balancing, because cells are functioning with each other in series and parallel. They are connected. So cells have to be balanced, the way they are charged and discharged, the way they are giving out energy and taking in energy. uh, so that is called as a balancing function. And then obviously the protection, like I told, it has to protect from overcharging. Because if suppose, I know it doesn't happen very often, but this is a use case scenario. Suppose the BMS fails, and the battery is overcharging, then they tend to catch fire or something like that. That is the case scenario that you might have heard in the news recently. So that is basically a reason for a bad BMS which has failed. So that is why even a lot of policies are being made to make sure that there are good BMS in place and all that. Yes. Let's talk about EV charging infrastructure now. So this is the AC slow charging, this thing. This is also called as level 2 charger. So whenever you buy an electric vehicle, say car or something like that, you would get a AC wall box, which is installed at your home or office, like as per your preference. So it is a slow charging because it takes time. So say you buy a Tata Nexon EV, it comes with almost a 29 to 30 kWh battery. So the charger, what they install at your home is 3.2. So it takes up about 11 hours to charge. So this is for overnight charging. So this is something for people who buy a scooter or any kind of vehicle, and the whole point is that they drive it all day and come back home and charge it at the comfort of the home. And it is a cheaper option because the electronics, the system, the hardware, everything is on the cheaper side. And then there is DC fast charging. This is a commercial fast charging, and it operates on three phase. So a 415 volt up to all the way to 480 also. The output will be 480, but input would be around the 415 volts. So this is something where people talk about this, this is something people talk about fast charging, when they say you can get 80% of vehicle charged in less than an hour. So this is the one where you're supposed to go. It cannot be done at home. So if you are thinking it can be done at home, it's a common misconception. I get that a lot, but this is somewhere you have to go. It's a commercial space. Yeah. And then there's some disturbance.
Sorry, Mr. Rahul, just to intervene you in the middle. I would request all the participants to keep them muted, please. I had requested this earlier. Sorry for the interruption, Mr. Rahul. You can proceed. Thank you.
No problem. Yeah. So in order to use this charging station, obviously they are commercial. You'll be paying a higher unit rate. Generally, I've seen a few in Mumbai and Chennai. So Chennai, they charge about 21 rupees per unit, and Mumbai, I've seen 23 rupees per unit. So I've seen it on the ground, and that is something people are okay to pay with. Considering one unit in a Tata Nexon EV would fetch you about 7 kilometers. So even if you are paying 21 rupees, it's 3 rupees per kilometer, which is not a big this thing. Yeah. So reasons for slow sales of electric vehicles. So people might have observed that it's a very hot topic, electric vehicles, but the sales are slow. And specifically I'm talking about cars, because cars is going to be the big revenue market. So one is, yes, cars are expensive other than Tata Nexon EV, which is again kind of not fitting in everyone's budget. I would say 14 lakhs is a lot to pay. Yes, but then there is Hyundai Kona, which is completely imported, which sells at 26, 27 lakhs. And then there's a MG ZS EV, which sells about 24 lakhs. So that's out of budget for most people. So that's why you might have seen, the adoption is low, and companies are now planning to get into making low cost. Tata is launching Altros maybe around 10 lakh rupees budget or something, maybe sometime next year. So it is getting better, but it's going to take a little bit time. But the scooter adoption, like I say, it makes complete sense to adopt a scooter like immediately. You can get a scooter like around 1 lakh, and if you actually buy a Honda Activa, it costs about 93, 94. It's not a different, not much, and you can charge this scooters at home using about 4 units, which would cost you about 24 rupees, and you can drive for 100 kilometers. Consider that with 40-kilometer range of Honda Activa, and you're paying 105 rupees per liter. So it is a big cost saving. So and the driving experience is also good. Like I said before, the vehicle have very smooth operations, and even with aging, you don't get any kind of noise. They have no vibration, which is kind of like a pain point if you see you're having a Activa or some kind of scooter. This is specifically the scooter. Again, the bike market is just picking up. It's a long way to go. And the second thing is not enough chargers. There's a common thing, like, it becomes like a chicken and egg story where people say there's not enough chargers. I don't want to buy an EV. EV companies say there's not enough, sales that I install chargers. So that becomes a thing. But considering there are vehicles, and not everybody drives so much per day. Nobody drives a scooter more than 60 kilometers, and any scooter in the market gives you comfortably, allows you to drive 60 kilometers. In fact, the minimum range starting is 75, 80. So you are okay to buy a EV and charge it at home. And then there's a chip shortage, which is actually happening. A lot of the semiconductor chips have been diverted towards 5G. So there's a lot of it's not only happening for EV, it's happening for the normal petrol, diesel, ICE vehicles also. But this is also one of the reason why demand is higher than the supply, and the prices are going high. But yes, that is something which is also a reason for slow sales. It's not only the public, there's also an issue with the supply. And battery fire risk. Recently, people have been hearing about batteries catching fire. Like I told before, it's a BMS issue, or sometimes the battery has heated, and it's not been detected by the BMS or the vehicle control unit. Depends on the make, obviously. Not every scooter has a VCU, so this kind of controlling and all, it becomes a problem. But yes, it actually speaking, battery vehicles, they catch fire. Yes, they do. But even the petrol diesel vehicles also catch fire. And if you look at the numbers, the percentage, the ratio, statistics, EVs globally, it has been proven that EVs catch less fire. And till today, nobody has been killed. That's a very good thing. I hope it continues. Yes. And myth and facts about EVs. So there's a myth that there's no adequate charging. Like I told before, nobody actually drives so much and all. So that is the same thing. The second myth also talks about, what if I runs out of charge and I get stranded. So here I've written, nobody drives more than 50 kilometers, and scooter companies are giving you 60 to 140 kilometers. Same thing with car, you get 110 kilometers to all the way to Nexon, which gives you 200 plus. And then the third myth is, electric car batteries pose a problem in recycling. So yes, it was a thing in the past, but today many companies have come forward where they are getting into recycling of batteries. So batteries, basically, they go to a plant where they are dismantled and segregated into two. One is a black mass, out of which you can remove nickel and cobalt, and the second is where you get copper, aluminum, and all that. So recycling, yes, it's being done. Let's talk about few frequently asked questions. Yeah. So I get this a lot. Can I buy a second hand, or a scooter or something or like that, or sell one? So this is something I get a lot. So I tell people, yes, you can buy one. Just make sure whenever you buy, look at the battery's SOH, like I was talking, state of health. If it is somewhere close to 85 or more, it's okay to buy. If it's below 80, then maybe ignore it, or maybe ask the seller to replace the battery and sell it to you. So that is something I tell. The motors, they are good. They're built to last for a very good time, so you don't need to worry about that. Other electronics, yes, everything has aging issues. I'm sure it happens in petrol diesel vehicles also. Yes, replacements would be a challenge, but if you are worried that it's going to stop somewhere or something, you have to look at the SOH. 85 plus percentage, it's okay. Same thing applies if you're buying an iPhone where it tells you the SOH. So battery health, you can look at it. And what is the charging time of an Indian EV? I already talked about Tata Nexon EV. Takes about 11 hours at home. You go to a fast charging DC station, 40% in 30 minutes, about 80% in an hour, which is good. You can get 170 to 180 kilometers in an hour of charging. And what is the range of an EV? Tata Nexon, they claim 312, you get about 200 something. And then there are scooters starting from all the way from 75. They go like Ola is giving 125. That is ARA rating, but in reality, you would be getting about 105 to 110. Are electric cars expensive to run? Like I told, they use very less amount of energy, and if you're charging at home, it makes a lot of sense to actually uh, uh, buy a car, electric car. It is very cheap. Tata Nexon is like 30 kWh. You would need about 35 units to charge. 35 units at home into 6 rupees would be 210 rupees, and you get about 210 kilometers. So you're running at 1 rupee per kilometer, which is not a possibility even in other things. Even CNG costs about 1.7 rupees. And do electric cars break down? No, they have very few. They have very few moving parts, so the chances are that it has very low. And then finally, can you drive an electric vehicle in the rain? So the battery, everything have good IP protection. Minimum IP65 is there, so you don't need to worry about all that. It is okay to drive it in a rain or get a car wash or something like that. It's completely protected. The electronics, the battery, and everything. Yes.